Hello and welcome to this video where we'll use PydanticAI, FastAPI and LanceDB to create a full-stack RAG application. And also we'll serve a frontend. We'll use Streamlit for simplicity, but it's very simple to change Streamlit to something else. This is what we're building. Take a look into this picture here. Here we have a backend, we have an API, we have a frontend. The backend, it consists of the agent, it consists of the vector database, which is built in LanceDB. And then we will have an API layer, which is a FastAPI layer. And then the frontend will consist of Streamlit. But it could be like TypePy, it could be React, it could be Solid.js, it could be Leptos, it could be whatever frontend you choose. The idea is that it's decoupled, and the frontend we start with here asking a question. So I'll call it RAGBit because this will be about the rabbit data, which we'll find from Wikipedia. I've basically downloaded it as PDF, and then we'll ingest the data in. However, we will ask a question to this RAGBit and then send this answer. We post it to the API. It's an API endpoint, and then it will call the agent and in the RAG agent, and there it will send it to the vector database and you will get an answer back. How does this vector database work? Take a look into this next picture. And in this picture, you can see this LanceDB database. It consists of several documents or articles. Each of these articles will be together the knowledge base of this database. This is the knowledge base for our RAG application. What we do is that when you have put it into LanceDB, it will track an embedding column for each of these documents. Each document will have an embedding. And an embedding is basically just a vector in many dimensions. And I think we'll choose 3072 because this is the embedding vector that we'll get from Gemini text. We'll use Gemini model to make the embeddings. We can see there's embedding 1, 2, 3 up to embedding n. And here you can also see that, for example, I write a query that's called describe a small cute rabbit. And this query will also be embedded. You can see the query vector here. And since you can see the query vector, you can see which document does which embedding vector in the knowledge base look most similar to. It finds basically the similarity, that is the angle between the vectors. And you can see that embedding 1 is closest. That means that it will retrieve the document 1, and this document 1 will be used as a context to the LLM that it can compose its answer based on this document 1. That is how RAG works. This is Retrieval-Augmented Generation. Let's move on to Visual Studio Code, where I'll code this out for you. Here in Visual Studio Code, let's do some basic setups. I will have backend, I will have frontend, I will have knowledge plate, and I will have data. And here I will paste in the data, and I will have assets where I'll paste in some images. This is all I want for the folders. And then I will create a few Python scripts. Here, touch, let's see, what do I need? API, ingestion, and we'll work with PDF. I need to have PDFs to text, and then .py. These are the Python scripts that I will create, and I will also create touch exploration stuff IPB. Now I have a few Python scripts and a Jupyter notebook. I will need to do UV init. This is just the setup. I will remove main.py, remove that one, and then I will do UV add. Now you can see there is no .ven, but after I do UV add, we'll have a .ven. I need to do UV add IPy kernel to work with Jupyter Notebook. I will have Google -generative AI. I will have FastAPI, UVcorn. I need Pydantic-AI, and LanceDB. I need also LanceDB, and if I need something else, I will install it on the way. Pandas I might need also. Pandas. Is that all? Maybe, yes. Frontend will need Streamlit. If I will use that one like this will install a lot of things, but UV is incredibly fast and awesome. It is done, and now we will go into my backend, cd backend, to create a few things there. I will do touch. What else? What do I need in my backend? I need to have constants, comma, data models, comma, rag.py. Now you can see my backend has a few things. I will add touch to the front end. I will just take app.py. And I think this is it, my friend. And now I will also, before I start out and code this, I will pause the video and I will put in my data. But also before that, I will do touch.env. Now you have a .env here, and make sure that in the git ignore that you also add .env like this, that it doesn't get tracked. And then .env, what we need is Google_API_key. And here you just paste in your Gemini API key, which you can get for free, and it has a really nice free tier that we will work with. And also, if you don't want to use Google API key Gemini, you can use OpenAI if you want. You can even you can use your own open source model. That's the beauty with PydanticAI, that it's model agnostic. We can choose whatever model we want. Here I will use Google API key. I would put in my Gemini API. I won't show you that, but this is the format, how it should look like. Close it down, and then I will put in the data. I've added the images and I've added my env. This is how it looks like. Now you see that we have some images and we have some data as well. Here's just a few images that I will use in my Streamlit application to show which source we have picked from. And take a look into the names. I have dwarfhotot.png, dwarfrabbit.png, etc. These are the same names as the data here, but except for, you can see this is capital letters. These were, I downloaded them from Wikipedia, and you can see this is just PDFs. It's from Wikipedia, and you can see this is the text. You can see this text here. Very cute rabbits. Let's get started. We'll get started with, I want to have this data in TXT format, not PDFs. Then I will go into this PDFs to TXT, and let's jump into this. We need to use from PyPDF. Actually, this needs to be installed. UV add PyPDF. Done. Now I have from PyPDF import PDF reader. Then we can do something in style with this. Actually, I want to go into my instance in the backend, because I need to, here I want to do from pathlib import path. Actually, I can show this at the same time that you can see in my paths. Here I want to have path to my data. Based on these constants, what we need to do is path done the file dot parents of 1 / data. This is the data path. And I will have a database path as well. I'll call this vector database path, and then the file dot parent 1 / knowledge base, something like this. And now What I want to do is that I want to go into my PDFs to text, and I want to do something in style of this. From backend dot constants import data path, because I want to have my data. What I want to do is to do something like this. Reader equals to PDF reader. Here I will place in the path. And the path is basically data path. This gives me the reader, and I will show you something. I will do hashtag %. This means that I actually can work with this as Jupyter notebook cells, or you run it using Control Enter, and you get it into an interactive mode similar to Jupyter notebook. This is how I work with when I want to explore this quickly. We get an error here. What is the error? PDF paths is a directory. Yeah, it is a directory. That's true. That's why it gives the error. But that is fine. But we find the one PydanticAI _rag/data. Then we cannot just we need to actually take the whole path. We have data path / let's say this one here, dwarf hot, dwarf _hot tot.pdf. And here I will run this again. And now you can see that this works. I can type out the reader and do enter, and you can see this is a reader.pdf reader. This doesn't help us much, but what we can do is that we can loop through this reader. I'll show you for page in reader.pages, and then you can do text equals to page.extract text, and we can do something in style of, let me put here, all text equals to nothing here. We will add the text, and we'll take, if there is text, if text is not none, then we can do all text plus equal to text plus \n. Extract text extracts the text for each page. We do for loop for page in reader.pages. And then what we can do is to type out, we can just run this first, command enter, and then I can do all text, command enter, and you can see this is the text. That is quite cool. We get dwarf, hot, country, origin, etc. This is basically the PDF here, dwarf, hot. Here you can see it started here, country, France of origin. Country, the France, use show, etc. And then you come into the text. Basically, what it does is that we have passed the text from the PDF into just text. What we can do as this one works, I can just copy this one and place it here. Using the interactive mode is quite nice because you can explore it at the same time. Here I will place this one into, I will close down this so that we get more space. And now I can do def extract text from PDF, and I will take the path. It returns a string. And now I can just return my all text. Something like this. Then we can also export the text. The export text to txt, text, comma, export. What this does is that we will put in the text and export path, and then it will export the txt. We need to open this one. We'll choose export path, comma, W as file, and then you can do file.write text. What we need to change here is this one. This is hard-coded. I don't want this one anymore. Instead, I'll just move it down here. And I will use this one if Dunder name equals to Dunder main. Then we'll have this. And we can use this path to, this is the path to this one, but I don't actually want to just have this one. I want to do something in style of this. I'll show you how this one works in Jupyter Notebook. You can see the path is this POSIX path to the AI RAG data. What you can do is something in style of this path.glob. Here you can choose the pattern, and I'll choose star.pdf. And you can see this one gives back a generator object. If it's a generator object, we can just make it into a tuple, for example. If I make it into a tuple, and you can see the POSIX path, this is the path to PydanticAI RAG data / dwarf.pdf, holland.lock.pdf, etc. That is quite cool. This means that we have the paths to our data by doing this path.glob. As it's a generator object, it means that we can iterate through it. What I want to do is something in style of iterating over this generator, and then I want to do with open, or I want to do basically extract text from PDF. The path is this one, data path. We can do for PDF path in data path.glob star.pdf. This is exactly what I wrote in the interactive mode. And we can have PDF text equals to extract text from PDF. And we can place in our PDF path. This means that for each of the paths, for each of these PDF documents, I extract the text into PDF text because it returns all text. And as it does that, we can do file name as well. It's fstring. Sten means that we'll pick the path, the name of the file without the suffix. This is the sten. And then .casefile, and then .txt. I want to save it as txt files. And then now I have the file name. I can basically just do export text to txt. And I place in my data folder. I will have all these, but lower cases and .txt. That is the idea. And now it's if the main. What we can do is open up a terminal and just do uv run PDFs to text. I run it and you can see, perfect. We get txt files. And take a look into that one. Dwarf rabbit, hot, Holland lock, Netherlands dwarf. Perfect. Close this down. This was now we have created our data. That was just creating txt data. Now it is time for doing some ingestion. This means that we will ingest this text data, these txt files, into our vector database. We have come to this stage. To do this, we will set up our vector DB. We will need to do from LanceDB, import LanceDB, and then we'll do from backend.constants import. We need to have our vector database path. We need to have our data path. And then we will also need to have an article model. I will put it into data models actually. In data model, we will have from Pydantic import base model and field, because we'll need that later. But from LanceDB.embeddings import get registry, and from LanceDB.Pydantic import lance model, vector. In order for you to understand this, you should have watched my video about LanceDB and vector databases. Otherwise, this one will be quite tricky to understand. And also we need to do from.env import load.env, because we need to load.env since we will use Gemini now. We'll have to create an embedding model. Why am I doing this? I will explain, because we need to have an embedding model which we will put into our Lance model. It's a model where it will automatically create the embeddings for us. Whenever you type in text, you put in text into this model and it will automatically create an embedding model. And also when you do query, you can search typing in just text and it will give the closest matches to its knowledge database. Embedding model equals to get registry dot get. Here we'll have Gemini dash text dot create, and here I will have name equals to Gemini dash embedding dash 001. This is my embedding model. And I also have an embedding dimension equals to 3072. This is, you just check the embedding dimension of this model and you will get this one. And then I'll create a class, article. This is a Lance model. A Lance model is basically just a Pydantic base model, but it is created in it is in such a way that you can use it to create a table inside of LanceDB. Lance model. And for this I will have a document ID as a string. What we need to this for is to just keep track that we don't get to duplicate documents, because document ID, doc ID, or article ID, because this makes it the ingestion idempotent in case I run it several times, for example. I'll use this one to delete the already existing ones. And then I want to keep track of some metadata. I want to have the file path. I want to have the file name as well. This is a string. And it's good to have a description. Here I will actually call this the stem of the file, i.e. without the suffix. And I will have a content is a string. This is the actual text content, and this is the embedding model dot source field. This is the column that will be used for calculating the vector embeddings. And then we have embedding. Embedding is a vector of the embedding dimension. We have vector 3072 equals the embedding model, which we have created using the get registry to get this particular embedding model. You can choose whichever embedding model you want. Dot vector field. This one means that it will automatically, whenever you put in some content, it will automatically compute this embedding, these vectors for us. This is a quite good start for data models. I will use this one in my ingestion. That is the idea. I'll go into ingestion now. And here I will do from backend dot data models import Lance model. And then I will also need to, oh no, not Lance model. I will pick, I pick article it's called. And then I will also need, what else do I need? I need to have, I will create and do setup enter DB, pop, and then the vector DB. This is our knowledge base, and we'll do LanceDB.connect. .connect URI equals to path. This is the database path, vector database path. And then when we have connected it, we want to do vector db.create table. I'll call this table articles. schema equals the article. This is the data model, the Lance model, which we have imported. It means that it will follow the schema which we defined earlier. And then x equals true to make it idempotent. Yeah, if you run it again, it already exists, it will do nothing. Return vector db. I set up the vector db. And now I will do def ingest docs to vector db table. What I want to do is that I want to take my documents or all my text files and I want to read them in, and then I want to add them into the table. This is the idea. Remember what we did earlier in when we did PDFs to text, we used glob. We need to pick from constant, backend.constants. Yeah, we have backend.constants. We already have data path. Cool. For file in data path.glob. But now the pattern is star.txt. I want to match all my txt files. With open file, read as f, and then I will do content equals to f.read. This means I will read all the text into this content, and I will do something else. I will do doc.id equals to file.stem. I'll just remove all the suffix and I will remove all the path to just keep the document name. I will use the document name as the doc ID. And then I will do table.delete. Table.delete is basically just an SQL operation. I will do delete, and then you have doc ID equals to doc ID. This is similar to delete where ID equals to doc ID. You need to have a quote here as well. This means that if it doesn't exist, then it will do nothing. But if it exists, it will delete it. This makes it idempotent. And with this, we can continue. We can do table.add. What do I want to add? I want to add we need to put it in a list and a list of each record. What is a record? That is a dictionary. And basically doc ID is doc ID, comma, file path. We have string of file name. This is the absolute path, basically. File name, file.stem. This is the file name. Or I could pick the doc ID, basically. But it's the same. Content is the content which we have read in here. That is it, my friends. Let us also do something like this. We're inside the for loop. I want to do something like this. Time.sleep 30, because I need to import time. Since I don't want to make too many API calls, I will wait for this to run to make it run the embedding model. I will give it some time, and I will also do some print here. I would say like table.pandas, that you can see the output of it. Since it's a pandas data frame, we can pick out the file name. We can pick out this column. And with this, we will do the guardrail if dunder name equals to dunder main. And here we'll have vector db equals to setup vector db of our vector database path. And then we will do ingest docs to vector db. And here we'll pick vector db. And which table do we pick? We pick this articles tables. This syntax, when I do like this with the dunder get item, we will actually get back the table articles. Now I will run this and I will pause the video to make it run for, I think, 2 minutes, because I only have 4. And then I'll come back. We have managed to run it, and you can see here is the output. started with one Holland Lap, and then we had the Netherlands Dwarf Rabbit as well, and we get Dwarf Hot, etc. This means that we should have the data inside of our knowledge base or our vector database. Let's try that out. We'll go into explorations and try out, I'll call it explore knowledge base. We'll change this one to our Python. Let's see, Pydantic RAG. Yes, perfect. Change this one to Python. And now I will import LanceDB. And then db equals to LanceDB.connect. And here we have URI equals to whatever the URI is. So the URI, you need to find the knowledge base. We have here knowledge base. This is our DB. If I run this one, we should get our DB back. We have knowledge base, and then we could have DB or I can call it the vector DB since I use it later on. And then we can call it vector DB. You can take a look into vectordb.table place, and you can see this is actually a method. You need to run it, and you can see we have articles. To actually get the articles tables, we need to do vector DB, and then using the get item, we take the articles here. Now you have the articles, and you can see it's inside of version 9 because we have put in data a few times. And you can also see that here vector, this is a Lance table. We can take a look what's inside by doing dot to pandas, for example. It's a PyArrow table by default, but we can take it and change it to pandas. Let me decrease this a little bit to show you. Now you can see there's doc.id. This is the names of the files, and here are the file paths. And here are the file names. File name, actually the same as doc.id. And we have content. This is the content for each of them. And here is very importantly, we have the embedding. For example, here you can take a look into vector DB. Let's see, what was it called? It's called articles. And then you can take dot search, and we can search for short rabbits. A short rabbit. And then this is a query. This is a query builder. You can take, for example, limit 3 to show the top 3 results. And you can see it's still a query builder, but you can take to pandas, for example, or to lists. You can take to list. Bound method to list like this, and you can see it looks like this. We have this list of dictionaries. This is actually 3 dictionaries, but you can see here, this is a list of dictionaries where we have each dictionary is a record where we have doc.id, file path, file name, and then content. It means that this one, the 0th one, if I take of 0, this is the closest vector or the closest document or the closest article. You can see it's this dwarf rabbit that is closest. This is the closest one, and then you could pick out the content by taking like this. Sorry, I make it a little bit too long here. It's maybe a little bit difficult to read, but if you take content here, you get out the content. This is basically the approach that we will be taking, but I will divide it into nicer format. But basically now do a vector search based on the user query. User queries something. This is put into the vector database and doing a search to find the closest documents. And then we pick the first document and use this one to actually create our answer. Then this is the content or this context that we'll put into the LLM, put into the agent to actually run to compose its answer based on this one. This is the idea. I will close down explorations now, and we will close down. I will go into data models to create some more models here. We have the article for the table to LanceDB table, but now we want to have models for the prompt based model. This one is basically just a prompt. It's a string. The type is string, and it has a field. We put in description, prompt from user. If empty, consider it as missing. And then we'll have class RAG response. I want this to have a certain format as well. I can work further with it. I want to be able to use some fields here. File name is one. String equals to field. Description. And here I have file name of retrieved file without subjects. This is the file name that I want. I have file path. I do Shift Alt down button. And here I will have absolute path to the retrieve file because I want to have a source. So I want to show where the document comes from. Which answer is a string. It's a field of description. Answer based on the retrieve file. If this is like I'm using these descriptions, and the descriptions, when we send this into the PydanticAI agent, it will read this description. It's good to have good descriptions. This is data models. Let's go on to build the RAG model. For the RAG model, we do like this. From PydanticAI, import agent. Now we'll create our AI agent, or basically just a wrapper for our model, the LLM, basically. We're not making the system agentic in any way. From backend, I need to do this. Backend.data models. Why do I use from backend? Because I want to use my API here, and based on the API, the data models is inside of the backend. That's why I need to refer it using backend. I'm not building a package now. I'm just working in this way. API, it will, for it, like in the scope of the API, the data models are inside of backend. That is how we will work, because we will use the API to import the RAG model later on. Data model, I have import RAG response. From backend.constants, I want to import vector database path, and then I want to import LanceDB. VectorDB equals to LanceDB.connect. URI equals to vector database path, and then we'll have RAG agent equals to agent, and here we'll have a model of Google, let's say 2.5 flat. We tried to system prompt a tuple. Here I will put in a few system prompts. I won't type it out. I'll just paste it in from my lecture notes. You can read it now. You are an expert in rabbit races and knows how to distinguish between the rabbits. Always answer based on the retrieved knowledge, but you can mix in your expertise to make the answer more coherent. Don't hallucinate. Rather say you can't answer it if the user prompts outside of a retrieved knowledge. Make sure to keep the answer clear and concise, getting to the point directly, max 6 sentences. Also describe which file you have used as source. This is my RAG agent. I want its output type to be our RAG response, that it formats it in the way of our Pydantic model. And then this is cool pattern that they have implemented in PydanticAI, is that I can add tools which the agent can use on the fly. This could be my base agent. And then I can add tools whenever I need. And tools could be like I use my LanceDB as a tool. This is super cool. Look at this. Add RAG agent dot tool plain. This means that I won't put in something called a context. I won't talk about that now because we're not talking about dependencies now, dependency injection. This is basically just a plain tool, which is a function that it can use. Then retrieve top documents query is a string k equals to 3. These are the top 3. It returns a string. And I will give it a doc string. This makes the agent be possible to read and understand what to use this tool for. Uses vector search to find the closest k matching documents to the query. You can choose to use this tool or not. And you can see here it says that always answer based on the retrieved knowledge. Retrieve top documents, retrieve knowledge. It understands that it should use this tool. This is quite cool. Results equals to vector DB of articles dot search. What am I searching for? I'm searching for my query is equal to query. It will put in the query here. It will put in what the user asks it. And then we take dot limits. We get back k results dot to list. These are my results. And remember when we did the explorations, how to pick out the values from here. It will return an f string that will look like this. File name. Actually, I can do like this. File name. Results. 0. 0 is the top result. You can actually pick that out if you wanted to. You could say top results equals to results of 0, and then we could pick out top result of file name, and then comma, file path, top results of file path, content, results, top result, or content. This means that this is the context that it will use. It will get back data in the form of. When you ask a question, this agent will use this tool. It will send in the user's question here to the query. And based on that, it will search the top document and then, or the top 3 documents, and then it will pick out the top document. It will pick out the file name, the file path, and the content from the top document. And it will be returned as a context which this agent will be using. Sorry, I said that this wasn't an agent before, but actually it is an agent. It is using tools. It has this context, and based on this context, it will run this. It will, based on its system prompt, compose an answer. And then the answer, it will output it in the output type, this RAG response, which we have forced it to look like this. This will be, we will get a structured answer. It is cool. At least theoretically. We'll take a look into how it works. And we'll test it out. To test it out, we'll build an API around this one. The API is super simple. From FastAPI, import FastAPI. from backend.rag, import RAG agent, from backend.data models, import from, and this is basically it. App equals to FastAPI, and then we can do app.post /rag/query async def query documentation query. We put in the use type as a prompt. Result equals to await rag agent dot run, and we put in query dot prompt. That is it, and we return our result dot output. And it will change. FastAPI will make it back into a JSON. Oh, let's go into our terminal to run this. What do I have here? I have the API. UV run UV core. API : -reload. Oh, let's see why. Address already in use. Yeah, of course. I have my preparation. I will close them down. I will run it again. UV run UV core API : app. Perfect. It runs. This is my browser /docs post. Good. Let's try it out. A really cute rabbits. That really cute rabbit. Show me what it eats. Something like this. We get something back. Ha! It worked. Netherland dwarf is the file name. A Netherland dwarf rabbit's diet should include an unlimited supply of hay, vegetables, especially dark leafy greens, blah blah blah. Yes. And if you read about this one, it actually exists. Let me ask something that doesn't exist. And give me a joke about rabbits. Maybe it exists, maybe it doesn't. I'm not sure. Yeah, none. I'm sorry, I can't provide a joke about rabbits, as my purpose is to answer questions based on retrieved knowledge about rabbit races, and I don't have access to a joke database. Cool! I love this. It works. When you have the FastAPI working, we could just simply consume it using the front end of our choice. This is our next step. It's time to create a Streamlit application to consume the backend and consume the FastAPI. Let's create import Streamlit as st, import requests from pathlib, import path, and I will have the assets path here equals to path. Actually, I need to do it in this way. I need to do absolute, and then the parent one assets. That is what I need to do. And then after that, I will do def layout. And here I'll create my Streamlit application. Markdown. I will call this ragbit c.markdown. Ask a question about different dwarf rabbits. Actually, I can leave that one. And then I'll have text input equals to st.text input. Label equals to ask a question. And if st.button, we have a button called send. Yes, and text input not equals to empty string, and then I want to have a response equals to requests dot post. And if you take a look into here, we can take a look into this endpoint here. Copy that one. This is the endpoint, and then I will have JSON equals to If you took a look into the JSON, it's basically like this. It's a dictionary. Key is prompt, and the value is the text input. We have prompt, small letters, value, text input. That is my response. And after the response is processed, we get the data is the response.json, and we can do st.markdown. Let's see, question, colon, and copy that one, and we'll copy this again, use some space in between, and here I can have the answer. The answer is data or answer. I get back here, you can see the answer with small area pause. And then we get, what do we more get? We get file name and file path. I can get here is source. And for the source, I could have data or file path. This is my source. And then I could have an image, st.image. It assets path. And then I will put in f-string or data of file name, and then .png, basically as that. We get the file name .png, and we get the assets path divided by that. We'll concatenate that path, and we should be able to get our image out. That was a layout, and then we just put in the guardrail. Name equals done domain. And we can just run the layout here. Yes, as simple as that. I create a new shell, and here I will just do uv run streamlit to run frontend slash what's called app.py. And we can get this RAG bit out, and I will ask a question about which is the cutest rabbit, something like that. String object is not callable. Let's see, string object is not callable. It's 13. Let's see. Text input is not callable. It's a string. Send this again. Or maybe, yeah, I did that. Yes, it cannot. I cannot objectively determine the cutest rabbit, as cuteness is subjective and varies from person to person. However, based on the retrieved document, dwarf rabbits such as Netherland dwarf are noted for the small stature and neotonic features like a short neck and rounded face, which some people find appealing. The file used to provide this context is dwarf rabbit. Nice. And then we get the image of a dwarf rabbit. Awesome. Give me the diet of a dwarf rabbit. Then we should get the same picture actually. Or yeah, they didn't have it there, but in the Netherlands dwarf rabbits, this was the closest one according to our vector search. It says, yeah, how the diet is, and you get the source, and this is the image of it. Nice. Now we have a full stack application. Fullstack RAG application. That is really cool. What is left is that we will, in another video, we will take this RAG pipeline or what the RAG application, and we will deploy, at least we'll just deploy the FastAPI to Azure Function app. And then you could deploy like the Streamlit to maybe Streamlit Cloud, or you could deploy it to Azure Web App as well, or somewhere else. That is fine also. But for me, in the next video, I will just deploy the FastAPI into Azure Functions to show you how that works. I will close this down, Control-C, and then make sure to commit and push your changes to Git and GitHub. What a ride! This was a very long lecture, but we managed to build it from scratch. A full stack RAG application, even if it was quite simple in terms of the front end, the backend shows clearly that, we were able to make a RAG agent. We were able to we started with PDF data, and then we created text files from it, passed it, created text files. We ingested those text files into the vector database LanceDB, and we used LanceDB together with the RAG agent, the PydanticAI agent, and we used the LanceDB as a tool. That is really cool that we could do that. And then afterwards, we created a FastAPI layer with it, and we just served one endpoint. We served the query, a RAG/query, and then we consume this using a Streamlit application and being able to show the data and together with the metadata. To get the data and metadata in a structured format, we used normal Pydantic to achieve that, which we could just put in as the output type to our Pydantic agent. Everything seems to flow very, very nicely. I really enjoyed making this video, and I hope that you learned a lot watching this. Thank you, and see you in the next one where we'll actually deploy it as well, or we'll just deploy the FastAPI application into Azure Function app, because I have a lot of other videos showing how to deploy Streamlit application and similar frontend to web apps. I won't do that deployment in the next video. But see you there. Bye.